In class on Tuesday, we took a look at inductive reasoning. Inductive reasoning allows us to look at patterns and to use those patterns or examples to reach a generalization. Today, we're going to be looking at deductive reasoning. Deductive reasoning is where we look at facts and use facts to reach a conclusion. The definition of deductive reasoning is the process of reaching necessary conclusions from given facts or hypotheses. So hypotheses is the plural of hypothesis, and basically hypotheses or hypothesis is a given fact. In example 1, we have two hypotheses that we use to lead to a conclusion. The hypotheses are all rectangles are parallelograms, all parallelograms are quadrilaterals. We can use those two hypotheses to reach the conclusion that all rectangles are quadrilaterals. In the second example, we have hypotheses that state Watson was playing billiards today, and Watson plays billiards only with Thurston. We can use those two hypotheses to reach the conclusion that Watson was playing billiards with Thurston today. With deductive reasoning, typically we see our hypotheses and conclusions written in a format called the if-then format. And basically what we do with that if-then format is that we put the word if in front of the hypotheses and put the word then in front of the conclusion. So if we were to rewrite example 1 in if-then format, it would read, if all rectangles are parallelograms and all parallelograms are quadrilaterals, then all rectangles are quadrilaterals. The same is true for example 2. We could rewrite it as, if Watson was playing billiards today and Watson plays billiards only with Thurston, then Watson was playing billiards with Thurston today. So we're going to practice finding the conclusion given some hypotheses. In the first example here, we have if all numbers that are divisible by 2 are even, and 264 is divisible by 2, then what conclusion can we make? Numbers that are divisible by 2 are even, 264 is divisible by 2. The conclusion we can make then is that 264 is even. In B, if x is equal to 5 and y is equal to 2x plus 3, then, so if we take that x equal 5 and we substitute it in for the x there, that's 2 times 5 is 10, so then we can say that y is equal to 13. And then the last example here we have, if a hat and scarf cost $15 together, and if the hat costs $7, then, so it's a hat and scarf, the hat is 7, so then the scarf is $8. So we're going to move on now to representing hypotheses and conclusions using a Venn diagram. If we look at the hypotheses that we have here, we see that we have two statements here. First one says that all people are mortal. So what we're going to do is a Venn diagram uses circles as an illustration. So we're going to start off with a big circle here that represents mortals. And then inside the mortal group, we have a group that fits inside there, and that's people. People are mortals. And inside of that, we can see that it says that Socrates is a person. So Socrates belongs inside the people circle. So we're going to use a little dot to represent Socrates. So we have M representing mortals, and inside mortals, we have a subset of people, and inside that subset of people we have Socrates. So the conclusion that we can make then is that Socrates is mortal, since he's inside the mortal circle. So our conclusion is Socrates is mortal. So with these types of problems, what you're going to need to be able to do is you're going to need to be able to draw the Venn diagram, draw your circles here to represent it, and then also come up with the conclusion. So let's look at another one. In problem number 2, we are looking at 2 hypotheses that deal with doctors. So it says all doctors are college graduates. So we're going to have a very large group here that represents college graduates. And we're going to have all doctors are going to be inside college graduates. Okay. And then we have a statement that says all college graduates finish high school. So this one's slightly different. We need to take our college graduate group, so this group here, the college graduates is going to fall inside the finishing high school group. So we're actually going to draw another circle, and this circle here is actually going to be on the outside. So we have college graduates falling inside the finishing high school. So then the conclusion that we can make is we already know that doctors are college graduates, and we already know that college graduates finish high school, so we're going to link doctors to high school, and so we're going to be able to say that all doctors finish high school. So our conclusion is all doctors finish high school. Some things you need to be aware of is that sometimes you can be given some false information or false facts. So if we follow valid deductive reasoning, sometimes it's going to lead us to a false conclusion because the information we were given at the beginning was incorrect. So false hypotheses will lead to false conclusions. So in this very first example, we can see that we have a hypothesis that says that a square is also a rectangle. And then we have another statement that says all rectangles have 6 sides. So we know that the statement 1, a square is also a rectangle, is a true statement. Statement 2 is a false statement. Rectangles do not have 6 sides. But that's what we're given. So if we use valid deductive reasoning and link together that the fact that a square is a rectangle and that rectangles have 6 sides, the conclusion we would come up with is that a square has 6 sides. Now we know that that conclusion is false. But if we follow the deductive reasoning and assuming that those hypotheses are true, that would be the conclusion we end up with. The same is true if we look at example 2. In example 2, we see that all doctors are college graduates, which sounds like a valid statement. And then the second statement is that all college graduates like to dance, which may or may not be true. Like you could have a college graduate that does like to dance, you might have a college graduate that does not. So that statement is not a true statement. But if we use our valid deductive reasoning and link together doctors to dancing, our conclusion that we would end up with would be the conclusion that all doctors like to dance. And that statement would, of course, be false because of this claim or that fact that was given there. In section 1.2, before we go into some practice, we're going to end with a couple rules of logic. And we have 4 important rules of logic. The first rule here is that if the hypotheses that we're given are true and the deductive reasoning that we're using is valid, then the conclusion must be true. So if we're given facts or hypotheses that are true and we follow along deductive reasoning the way we're supposed to, we'll end up with a true conclusion. Number 2 tells us, though, that if our hypotheses are false, which is what we looked at on that last slide, and our deductive reasoning is valid, then the conclusion must be false. So those 2 things there we should feel pretty good about. If we have true statements and true facts and we follow our deductive reasoning, we're going to get a true conclusion. If we have facts that are really false, we're going to end up with a false conclusion. Number 3 here sometimes gives students a little bit of trouble here. This is called affirming the hypotheses. And so what happens is if we're given a true if-then statement and a specific example is given in which the hypothesis is true, we can deduce that the then part is true. So affirming means like agreeing with the hypothesis. So in this example here that we're looking at, if you have your teeth cleaned twice a year, you will have less tooth decay. So that's your true if-then statement. If you have your teeth cleaned twice a year, you'll have less tooth decay. If we then link that to a specific example where the hypothesis is true, so we have Sarah who does clean her teeth twice a year. So she's following the statement that's already given, the hypothesis that's given. So suppose Sarah has her teeth cleaned twice a year, what can we conclude? So because Sarah is following what the hypothesis says, she's having her teeth cleaned twice a year, it is safe for us to conclude that Sarah will have less tooth decay. So that's an example of affirming the hypothesis. We'll try an example or 2 of this on the next slide. Then if we move on to number 4 is denying the conclusion. So again, we're going to be given a true if-then statement and then a specific example that we're going to look at. And if we look at the example and the conclusion we get is false, it doesn't match up with our initial if-then, we'll be able to deduce that the if part is false. So again, we're going to go ahead and look at the same example here of if-then, and that is if you have your teeth cleaned twice a year, you'll have less tooth decay. So that's our if-then statement, which is true. So now we're going to deny the conclusion. So we're going to say that Sarah has a lot of tooth decay. So we're denying the conclusion part. So that means that we can also conclude that the if part was false. And so that would mean that Sarah does not have her teeth cleaned twice a year. On the next slide, we'll practice a couple more examples of affirming the hypothesis and denying the conclusion. What you do want to remember is that when we affirm the hypothesis, our example is going to agree with the hypothesis, which means that the conclusion should follow what the if-then statement says. In number 4, when we deny the conclusion, when we look at our example, the conclusion's not going to match up with the if-then conclusion. It's going to be the opposite of it. So then we can take the opposite of the hypothesis. Let's apply some rules of logic to a couple of sample problems. In number 1, we have at the beginning of the term, your teacher says to the class, if you work hard, in this class and complete every assignment, then you'll do well in this class. Max did not do well in this class. What can you deduce? Justify your answer and by stating the rule of logic applied. So remember, our two big rules of logic are affirming the hypothesis and denying the conclusion. So in this particular case, we have a hypothesis that says if you work hard in class and complete every assignment, and then you have a conclusion that says then you will do well in class. So in the statement, Max did not do well in class, that matches up with the conclusion. And it is denying it, right? It says you will do well in class, and here Max did not do well in class. So we're denying the conclusion, which means we can deduce that Max did not work hard in class. And our justification is we are denying the conclusion. So in the specific example that was given, we see that the part of it that was given was denying the conclusion, did not do well in class. Because we denied the conclusion, that allows us to say then that he didn't work hard in the class. All right, let's look at another example. In example 2, it says that doctors say that if we wash our hands often, then you'll reduce your chances of getting sick. Emily washes her hands often. What can you deduce about Emily? So again, we can see that the hypothesis here is if you wash your hands often. And the conclusion is you'll reduce your chances of getting sick. So when we say Emily washes her hands often, we have Emily matching up with the hypothesis. And we're agreeing with the hypothesis. So that tells us that we are really affirming the hypothesis. And so when we affirm the hypothesis, that's going to allow us to deduce that Emily will reduce her chance of getting sick. So again, because the idea Emily washing her hands, or that phrase, matches up to what was said in the hypothesis, and it was in agreement with the hypothesis, we can come to a similar conclusion that she won't get sick, and that's called affirming the hypothesis. All right, so then if we take a look at 3 here, in number 3 it says, researchers say if you use your iPad, phone, or tablet right before you go to bed, you will have a harder time falling asleep. John does not use his device right before he goes to bed. What can you deduce about John? So we can see that the hypothesis here is if you use your iPad, tablet, phone right before you go to bed, that's our hypothesis. The conclusion is having the harder time going to sleep, so you'll have a harder time falling asleep. So when we look at the specific case, we have John's statement. John does not use his device, so it does not use his device right before he goes to bed. That is similar to the statement in the hypothesis. The difference is that we're denying the hypothesis. So it looks like we're denying the hypothesis. And because of that, we don't have any rule of logic that follows denying the hypothesis. So there's actually no conclusion can be reached. We cannot deduce anything nothing can be deduced because we don't have any rule of logic that follows denying the hypothesis. So we looked at 3 examples. An example where we denied the conclusion, which allowed us to negate the hypothesis. We looked at affirming the hypothesis, which allowed us then to deduce that the conclusion was going to follow the same as the actual if-then statement. And in statement 3, we weren't able to conclude anything because the specific example was denying the hypothesis. We're going to be moving on to section 1.3, which is looking at conditional statements. So far, we've looked at some if-then statements, and we know that if we have a true hypothesis, we'll reach a true conclusion if we follow valid deductive reasoning. If we have a false hypothesis, we'll end up reaching a false conclusion. We're going to take a look at a couple of different types of statements. The first statement is the converse of statements. The converse, or to write the converse of a conditional statement, what we do is we interchange or change the order of the hypothesis and conclusion. So in the conditional statement we have here, if you are at Angel Falls, then you're at the tallest waterfall in the world. To write the converse of it, we're going to take our hypothesis and take our conclusion and interchange them. So the converse is, if you are at the tallest waterfall in the world, then you are at Angel Falls. We want to practice writing the converse of each statement, and then we want to decide if the initial statement is true, if the converse is true. So in number 1, if a person lives in Massachusetts, then the person lives in Boston. Is that statement true? No. I have a relative that lives in Concord, and they live in Massachusetts. So just because they live in Massachusetts doesn't mean that they're going to live in Boston. I can see that the hypothesis, a person lives in Massachusetts, and the conclusion is the person lives in Boston. To write the converse, I need to just interchange the two. So I can say that if a person lives in Boston, then a person, or that person, lives in Massachusetts. Is that statement true? Actually, that statement is not true because we have Bostons in other states. So you could have a Boston, I'm not sure what particular state it is, but a Boston from another state. All right, let's take a look at the second example. If a wildflower is a goldenrod, then it is yellow. So in here we have a hypothesis is a wildflower is a goldenrod, and the conclusion is it is yellow. We can find the converse by interchanging these two. And our new statement would be, if a wildflower is yellow, then it is a golden rod. So for the initial statement, if a wildflower is a goldenrod, then it is yellow. That is true. Goldenrods are yellow. If we look at the second, the converse statement, if a wildflower is yellow, then it's a goldenrod. That's going to be false. It could be a goldenrod, but it could be another wildflower. If you end up having a conditional statement that's true and the converse of that statement is also true, we can rewrite that statement as an if and only if statement. So when we looked earlier on the last slide, we looked at if you're at Angel Falls, then you're at the tallest waterfall in the world. The converse of that was if you're at the tallest waterfall in the world, then you are at Angel Falls. Because both of those statements are true, we can combine the two statements into one if and only if statement. You are at Angel Falls if and only if you are at the tallest waterfall in the world. So our if and only if statements are a combination of two. We'll get some more practice with that in the Nearpod that you're going to work on. The next type of statement is called the inverse. To find the inverse of a conditional statement, what you're going to do is you're going to negate the hypothesis and the conclusion. So you're negating both. So if we go back to our initial conditional statement, if you are at Angel Falls, then you are at the tallest waterfall in the world. To write the inverse, we're going to keep the hypothesis and the conclusion in the same position, and we're just going to negate them. If you are not at Angel Falls, then you are not at the tallest waterfall in the world. So let's look at an example of this. In number 1, it says, if I see a rainbow, then it has just rained. So I can see that my hypothesis is I see a rainbow, and my conclusion is it has just rained. So to write the inverse of that, I'm just going to input the word not or negate the statement. So if I do not see a rainbow, then it has not just rained. And then I'm supposed to decide if that inverse is true. So if I do not see a rainbow, then it has not just rained. I'm going to say that that's false because there's lots of times where it has just rained and I have not been able to see a rainbow. So it could have rained and we just hadn't seen the rainbow. The last type of conditional statement is the contrapositive of the conditional statement. So the contrapositive is going to do what both the inverse and converse do. The contrapositive is going to negate both the hypothesis and the conclusion, and then it's going to interchange or change the order of the hypothesis and conclusion. So the conditional statement, if you're at Angel Falls, then you're at the tallest waterfall in the world. The contrapositive is going to be negating the hypothesis and conclusion and interchanging them. If you are not at the tallest waterfall in the world, then you are not at Angel Falls. And you can see a picture off to the side there of the actual waterfall, Angel Falls. So we're going to practice writing the conditional statement and determine whether it is true or false. So we have the statement here that if you live in Washington, that's our hypothesis, the conclusion is you need a raincoat. So if we want to write the contrapositive, we're going to need to negate both and interchange it. So our contrapositive would look like if you do not need a raincoat, then you do not live in Washington. If you do not need a raincoat, then you do not live in Washington. Does that statement appear to be true or false? We're going to say that that statement is false. If you do not need a raincoat, there's a lot of places we can, or you could be living in Washington and just don't need a raincoat on that particular day. The second statement, if the measure of an angle is 45 degrees, then the angle is acute. So the hypothesis is the measure of an angle is 45 degrees. The conclusion is the angle is acute. To write the contrapositive, we're going to interchange and negate. So we can say if the angle is not acute, then the measure of the angle is not 45 degrees. Is that statement true or false? If the angle is not acute, then the measure of the angle is not 45 degrees. If the angle is not acute, then the measure of the angle is not 45 degrees. So we can have an angle that's not acute, which would be 90 or bigger, and that means the angle measure is not 45 degrees. On this slide, we're going to bring it all together. We're going to take a conditional statement that we're given and write the converse, inverse, contrapositive, and possibly an if and only if statement. I'm going to point out right now that I have a typo here that I need to go back and eventually fix. It should say contrapositive. So if we look at our conditional statement, if today is October 31st, that's our hypothesis, then it is Halloween. That is our conclusion. So if we take the converse, remember the converse is when we interchange or change the order of the hypothesis and conclusion. So if we do that, change the order of the hypothesis and conclusion, our new statement will be, if it is Halloween, then today is October 31st. That's our converse. The contrapositive, I'm going to go down to that one next. The contrapositive is switching the order and negating. So my converse already switched the order. Now I just need to negate my new hypothesis and my new conclusion. So that's going to sound like, if it is not Halloween, then it is not October 31st. And now I'm going to move over to my inverse. The inverse is going to go back to my original conditional, and it's just going to negate the hypothesis and the conclusion. So it's going to say, if today is not October 31st, then it is not Halloween. Okay, and then the last thing I need to do here is I need to determine if the conditional statement and converse are both true. I need to write the statement as an if and only if statement. So if I look at my initial conditional statement, if today is October 31st, then it is Halloween. That looks like a true statement to me. If I look at the converse is here. If it is Halloween, then today is October 31st. That looks good to me as well if we're talking about the United States here. So we have two statements that are true. So I'm going to be able to combine them into one if and only if statement. And that statement's going to read, today is October 31st, if and only if it is Halloween. So hopefully you have a pretty decent understanding of our conditional statements and some of the rules of logic. I'm going to direct you to the Nearpod in Moodle, and you can check your understanding there.